Milky Way's origins revealed using Gaia Observatory. The Milky Way's origins have puzzled scientists since we first realized it's one of countless galaxies in our universe. Find out how scientists have applied information from the Gaia Space Observatory and the Sloan Digital Sky Survey to uncover two of our galaxy's earliest star streams. I didn't really understand the expression Milky Way until my parents started taking us camping and encouraging us to try stargazing. That's what introduced me to the cloudy band of light that stretches across an unspoiled night sky. Greek, Persian, and Chinese astronomers all mentioned the Milky Way in their writings. They realized it probably consisted of distant stars, but they could only speculate on its true nature. It was Galileo who first turned a telescope on the Milky Way and realized, to borrow a line from Arthur C. Clarke, "My God, it's full of stars." We now know that cloudy band of light is the view toward our galaxy's center. Once Galileo explained the Milky Way, scientists thought our galaxy was a kind of island universe, containing all the stars in the cosmos. Harlow Shapley showed that the Earth was nowhere near the center of this island. Then, by studying a class of stars called Cepheid variables, Edwin Hubble discovered the Andromeda Nebula was a separate galaxy. He soon realized that other spiral nebulae were also different galaxies, even further away than Andromeda. The Milky Way formed when the stars in its spherical halo region settled into a rotating disk. It has also merged with other galaxies and drawn in gas and stars from its surroundings. Dr. Kjati Malhan and his even more experienced colleague, Dr. Hans-Walter Rix, study how galaxies form, evolve, and move at the Max Planck Institute for Astronomy. They recently teamed up on a study that the Astrophysical Journal published this week. Their research focuses on the mergers that have led to our galaxy's formation. It was a bit like studying how a metropolis like New York grew by annexing neighboring communities like Brooklyn, Queens, Staten Island, the Bronx, and others. The team identified what seemed to be two of the Milky Way's earliest building blocks. They're naming them Shakti and Shiva, after the Hindu gods of creation and transformation, respectively. When we visualized the orbits of all these stars, two new structures stood out from the rest among stars of a certain chemical composition, Professor Malhan explained. We named them Shakti and Shiva. Until now, we had only recognized these very early fragments that came together to form the Milky Way's ancient heart, Professor Rix added. With Shakti and Shiva, we now see the first pieces that seem comparably old, but located further out. These signify the first steps of our galaxy's growth toward its present size. The scientists approached their task using data on 6 million stars gathered by the European Space Agency's, ESA's, Gaia Space Observatory. They combined that with detailed measurements from the landmark Sloan Digital Sky Survey. What's truly amazing is that we can detect these ancient structures at all, Professor Malhan said. The Milky Way has changed so significantly since these stars were born that we couldn't expect to recognize them so clearly as a group, but the unprecedented data we're getting from Gaia made it possible. The two building blocks, or star streams, lie in what astronomers call the Milky Way's Old Heart region, which holds our galaxy's oldest stars. Each of the newly identified streams has the mass of roughly 10 million suns, and the stars they contain are between 12 and 13 billion years old, making them older than the Milky Way's disk formation. The stars there are so ancient that they lack many of the heavier elements created in the universe's lifetime, Professor Rix explained. These heavy metals are those forged within stars and scattered through space when they die. The stars in our galaxy's heart are metal poor, so we dub this region the Milky Way's poor old heart. Even though we've only known about the Milky Way for about a century, understanding its origins still satisfies one of humanity's most ancient needs. We're all driven toward a better understanding of the universe and our place within it. Tying the Milky Way's creation story to the legends of Shakti and Shiva is a nod to the new story we're all learning to tell about the cosmos. The names for these new star streams reflect our Milky Way's awe-inspiring processes of creation and transformation. Dr. Timo Prusti, project scientist for Gaia at ESA, also commented on the Shiva and Shakti discoveries. We need to pinpoint the subtle yet crucial differences between stars in the Milky Way to understand how our galaxy formed and evolved. This requires incredibly precise data, and now, thanks to Gaia, we have that data. As we discover surprise parts of our galaxy, like the Shiva and Shakti streams, we're filling the gaps and painting a fuller picture of not only our current home, but our earliest cosmic history. We always have more to learn if we dare to know.